Hello everyone, and welcome to our notes on 1.2, which is all about measuring segments. And so we talked about when we are looking at lines, we cannot measure a line because it goes on in both opposite directions forever. However, a segment has two endpoints and it can be measured. So we can find the length of a segment. So the distance between 2 points A and B can be written as the length of segment AB or AB. And so to find that, we are going to take the absolute value of the difference of their coordinates. And so if I'm trying to find the length of AB, A is located at -1, and I'm going to subtract where B is located at 3. And so the reason I want to take the absolute value of that, -1 minus 3 is -4, is that we know that distance cannot be negative. When I am walking and my step count on my watch is increasing, that's because I'm taking steps. And even if I were to walk backwards, it's still going to increase in my step count. So same thing for driving a car. Whether you're in drive or reverse and you're backing up or going forward, it's still going to increase the mileage on your car. So what is the absolute value of 4? How far is that away from 0? It's going to be 4. You could count it just to verify. 1, 2, 3, 4. Honestly, most of the time you're probably going to count if it's on a graph like this where it is countable. But like, let's just say that our numbers were like 252 and -3,240. You wouldn't want to sit and count that. So we just find the difference of their coordinates and take the absolute value of that. So it says find the length of each segment. So since these do not have the segments written above it, I know that I'm going to be finding their length. So these should be numbers. Whenever it looks like this, all three of these answers should be numerical values. So let's find ST. ST goes from -4 all the way up to 8. So you can tell this is counting by twos. So 2, 4, 6, 8, 10, 12. Let's think of that numerically. If we wanted to do that with the absolute value, we'd go -4 minus 8. -4 minus 8 is the absolute value of -12, which is in fact equal to 12. Another way you can do this is just to think that from -4 to 0 is 4, from 8 to 0 is 8, and so 4 plus 8 is going to be a total of 12. UV is a lot easier to count. It goes from 10 to 14, so we know that the difference of that is going to be 4. Absolute value of 4 is 4. And then from S to V, from -4 all the way to +14, so -4 minus 14. That is going to be the distance from -4 to 0 is 4. From 14 to 0 is 14. So 4 plus 14 is 18. Or you could do it this way and say the difference is -18. So the absolute value of that is +18. All right. We are now going to start looking at the segment addition postulate. So the segment addition postulate literally just talks about adding different pieces of segments together. So the segment addition postulate states that if A, B, and C are collinear, and B is between A and C, so it's happening somewhere between these two endpoints, then we can use the segment addition postulate. And the segment addition postulate says that the length of AB plus the length of BC, those two little pieces, this piece plus this piece, is going to add up to the whole thing, which is AC. So the two smaller parts make the whole. So let's look at some examples of that. If A to B is 5, let's fill it in on the diagram, and B to C is 10, then what is the length of this whole thing? So if this piece is 5 and this piece is 10, we know that that whole thing, A to C, I just add those parts together. So that'd be 5 plus 10 is going to be equal to the length of AC, so that's going to be equal to 15 total. We can also use the segment addition postulate to find the smaller pieces. So if I know that this whole thing from T all the way to Q, if that whole thing is 25, and this little orange piece is 12, and this little blue piece is 3, how do I use that to find S to R, which is that unknown length? I can do 12 plus the little piece SR plus the 3 should add up to the 25. So I know that to find SR, I can take the whole thing, which is 25, and subtract off what I've spent at orange and at blue. So I took the pink amount, 25, and I subtracted what I spent at orange and what I spent at blue in order to find my unknown piece, which I'm going to do in red. So SR is going to be equal to 25 minus 12 minus 3. So that's going to be the same thing as 25 minus 15. And so what is left? If I've spent 12 and I've spent 3, I'm going to have 10 left for S to R. 10 is going to be SR. Okay? Why does that help me find S to Q? Because S to Q is going to be this piece 10 plus this piece 3, S to Q. So 10 plus 3 makes 13. All right, the next one's a little bit harder simply because it doesn't have a diagram already drawn for you. So if in doubt, we say this in my class all the time, if in doubt, draw it out. It says if point F lies on EG, okay, so let's go ahead and draw a segment EG. We don't know how long it is, so we're just winging it. If point F lies on EG and E to F is 59 and G to F is 24. So that means that E to F is going to be a little bit bigger than the other one, so it doesn't have to be perfect. E to F is 59, it says, from here to here. And then G to F is 24. What is the length of the whole thing, EG? Well, we know that EF plus FG should add up to the whole thing, EG. So by the segment addition postulate, that's going to be 59 plus 24 makes that whole thing, EG. So what is 59 plus 24? That is going to give me a length overall of 83. All right. Okay. Now we have a few different vocabulary words about segments. We have something called congruent segments. And this is the symbol for congruent. It's the equal sign with this little symbol over it. This means congruent. So we know that whenever you're saying that segments are congruent, if their lengths are equal, if AB is equal to CD, if two segments are equal in length, then those are going to be defined as congruent segments. And the symbol for congruent, we're going to see this a lot in the next semester, over the next semester, is that symbol right there. This is going to be written as by saying AB, segment AB, is going to be congruent to CD, which means that they have equal lengths. So if this is true, if the segments are congruent, their lengths are equal. It's also true the other way. If the lengths are equal, then the segments are congruent. Segments are going to be marked, congruent segments are going to be marked with tick marks. Okay, so when we do that, if I wanted to say that two segments were congruent, this segment would be marked congruent to this segment, and I would put a tick mark on each one. So this one is equal in length to this one. So AB would be congruent to CD. Okay. If we had more than one set, then I would mark them each with the single congruence mark. But then over here, let's just look at this example. There's A, B, and C, D, so let's call that something else. We've already used that in the picture, so let's call that E, F, and G, H. Those are congruent, but if you look over here, we have A, B is going to be 4 units long, and then CD is going to be 4 units long. So because each of those are 4 units long, that means that those segments are going to be congruent. So I could put 2 tick marks to show that, hey, this set is different. It's different in length than the EF and the GH, but those are the same. The ones with both have the 2 tick marks. So AB would be congruent to CD, and their lengths would be equal. All right, so then what is a midpoint? The midpoint of a segment is what it sounds like. It's going to be a point that divides the segment in the middle. So it's going to divide the segment into 2 congruent segments. It's going to cut it in the middle. So it's the point that does that. So if we have A to B is 3, and then B to C is 3, that means that B must be perfectly in the middle of this segment, so point B would be the midpoint. All right, so what is a segment bisector? Bi means 2, sect means to cut, and so a point, line, ray, or segment that goes through the midpoint of a segment is a segment bisector. So like if I were to draw something going through point B, that would be a segment bisector. So it could be a point, it could be a line, it could be a ray, whatever it is dividing the segment in half. So it's chopping it into 2 equal pieces. All right, so let's look at some using vocabulary words in problems, solve for the indicated values. If A to B is 4, so let's put that on here. If A to B is 4, and B is the midpoint, they're telling us from the beginning that B is the midpoint of the segment AC, what is the length of BC and what is the length of AC? So if B is the midpoint, I know I can add my tick marks. These lengths should be the same. The length of AB should be congruent or equal in length to the length of BC. Those segments should be congruent. So if that one is 4, then the length of BC should also be 4, just by the fact that it tells me it's the midpoint. So what is BC? BC would be 4. What is AC, this whole thing? Well, that's going to be 4 plus 4, which makes a total of 8. If each half is 4, then the whole thing is 8. All right, this one's a little bit harder, again, because it doesn't have a picture. So if in doubt, you're always going to draw it out. So if we know that DF is 42, so I'm just going to start with a segment. I'm going to label one side D, one end point F. And E is the midpoint, so I'm going to put it dead center in the middle. E is the midpoint, it says. If I know that E is the midpoint of DF, that means it's dead center in the middle. So I'm going to put 2 marks here and 2 marks here to show they're the same, since I've already used 1 in my previous example. What is the length of D to E and what is the length of E to F? If they tell me that the whole thing, D to F, is 42. From F to D is 42, and it says E is the midpoint. Well, if the whole thing is 42, what does that mean the midpoint does to it? It cuts it in half. So what is half of 42? Half of 42 is going to be 21 for each segment. Those are congruent segments. D to E is congruent to E to F. And so each of those would be 21, which is half of 42. So D to E is 21, and then E to F is also going to be 21. So your homework is the entire back page. This is just working with some segments before we add in the algebra next week. Hope you're having a great day.